Hello, everybody. My name is Warfield, and this is All Your Cloud or Belong to Us. A little bit about myself. I work for Microsoft as part of the Microsoft Security Response Center. My day job is making sure that you get Patch Tuesday every month if you run Windows. I own all of the vulnerabilities that come through for Hyper-V, for Windows, for all the server products, the kernel, which means that last year I got to handle the lovely vulnerability we called MS-1710, which turned into WannaCry, which turned into NotPetya, and I also got to own Spectre Meltdown, which, it's been a busy year. Before I worked for Microsoft, I spent about 18 years doing network engineering. I was a admitted gray hat. Since this is being recorded by the NSA, I'll say that. My first hack was over dial-up. I was like about 12 years old, and I've spoken at SAS this year, Troopers. You can find me on the Twitter there, and I have some code that I'm going to talk about that I post to GitHub just because it's a conflict of interest if I don't give it away for free. So, what happened? I think it's important. And I'm not going to run through these bullet points because I don't really think that it's necessary. You can read them yourselves. I'd like to start with a little anecdote. Back in the late 90s, I was one of the first kids in my neighborhood to get a cable modem. And I discovered in talking to a friend that was going to college across the country that once I convinced them to do an IP config all and send me their IP network information off their Windows box, I could plug it into Network Neighborhood, reboot, because it was Windows 95, and when after the thing came back up, it would browse, and I was able to browse all the subnets at their college, and I could see all the file shares, hit IPs with $, look at people's MP3s. Fast forward to when I came to Microsoft in 2014, I was trying to spin up an extra DNS IP address on a system we already served DNS through to the internet. It took me 6 weeks of paperwork and approvals and security reviews for DNS on 53 UDP, right? So the sort of thing I'm trying to get at is there was a lot of lessons that were learned the hard way that were fixed in 15, 18 years. Cloud networking comes along, and what I've been seeing is it seems like these trends that these improvements we were making are now going backwards, right? So we're seeing every single VM is being exposed to the internet. People are just spinning things up. They're leaving it there. They're not patching it. And what I'm going to get into here in a little bit is some of the configurations on these VMs that come out of these third-party like IaaS galleries are just ridiculously insecure, and which led us to 2017. Most of these are attacks that I had to track down in Azure. This stuff, with the exception of, I think, the S3 bucket stuff, which is not really my thing. That's more Chris Vickery. Actually, if you see Chris, I'd love to talk to him. Never met the guy. So, how did I start finding this stuff? August of 2016, one of the security feeds I was reading talked about people were going into these Redis machines and they were putting this key called Crackit in there. What this key was a root SSH key. Then they would come back to the machine, SSH in as root, do all sorts of nasty things to Redis. And I'm like, I had never heard of what Redis was, so I looked it up and I'm like, oh, okay, it's this NoSQL database system. Fast forward to about January, February of 2017, people start doing these attacks against Mongo and a whole bunch of other databases. The points that I say up here, they're not really trying to shame anybody, but those are quotes taken directly from the security pages of all these NoSQL products, right? They tell you in their security guidelines, don't put this on the internet, never expose this thing to the internet, set up a password. So when you tell somebody not to do something, what are they going to do? Put it on the internet. Mongo, Couch, Hadoop, Elastic, Redis, Cassandra. I thought there was another one, but I can't remember off the top of my head. What they were doing wasn't actually ransomwaring these things. They would come in, they would just drop the database, they would put a ransomware node in with a Bitcoin address and be like, hey, if you want your database back, just send us some Bitcoin to this address, which was, if you were foolish enough to do it, you're not going to get your data back. They didn't actually ransomware it. It wasn't encrypted. It was just gone. Globally, 100 plus, I think it was around 145,000 machines got hit with this between January and June of 2017. What I ended up doing was just looking at Wikipedia and figuring out what's going to be the next one that they go after, and it was almost clockwork that they were going after these things. Azure, we had about 3,800 customers that had this happen to them. So, how did I find this stuff in Azure? As you probably would imagine, Microsoft owns quite a few IP addresses. There's actually that number's a little wrong. We actually today have about 2.6 million IPs that are facing the internet at any given time, which if you've ever port scanned a network, port scanning is very slow, and the problem with a port scan is just because that port's open doesn't necessarily mean this database has actually been like compromised or been dropped. The other thing that was fun is that every NoSQL solution runs on a different port. So even if I was going to go and port scan 2.5 million IPs, tomorrow I'm going to have to do it again, or I'm going to have to do it again, I'm going to have to do it again. So the only way to find these things is to actually see the database names, right? So once you can't just port scan it. Even if I did, all I see is, okay, it's listening, right? I don't know what's there. It might not even be that thing. So I wish I told you I had a cool, fancy tool that Microsoft wrote ourselves, but no. I did all this with Shodan, which kind of tripped people out because they're like, I thought Shodan's just that site where you go and you find people's webcams and like stupid things they plugged into the internet. It's like, yeah, but you can also use it for blue team stuff. During WannaCry, we had to go and figure out how many SMB IPs we had that were facing the internet just to figure out what our risk was. Our team that had their own port scan solution said, no, your Shodan doesn't know what our network looks like. We're going to port scan it ourselves. I'm like, I can give you the data in 8 minutes. They're like, no, you don't know what you're talking about. 14 hours later, when they got done, they sent me this list of stuff, and I'm like, well, can I see what you found? So I deduped their list against my list. Out of 14,000 IP addresses, Shodan had 9 more than they did. So like less than 1% difference. And I'm like, dude, you could have had this yesterday. So the other nice thing too is I get all this metadata, right? I know what version of the operating system it's running. I can see like everything is searchable. I can see the database names, and I can dump it all out through JSON, which was really useful at first. And I would just say, okay, what I ended up doing was going to Wikipedia, say, find all of these different products, and I would just download everything that was in my IP space and start looking around. And I was starting to catch these attacks within like a couple of days of when they'd started. That was less than efficient, and I like to think that most of us are lazy, so we write code to automate the stupid stuff. So I talked to John Matherly, the guy that built Shodan, and said, dude, you know what you should do? You should just do this stuff like natively inside of Shodan. And he's like, okay, write the code, I'll put it in there. So I did. Last year, December, we plugged this code in. I've since added, I think, 2 different database solutions and double the number of database names. So what do? Is you can go to Shodan, you can search for tag compromised. This will tell you any database that's been seen and looks to be compromised. When I was updating these slides a couple days ago, there's still like 37,000 of these things on the internet. The one thing I have to point out, Shodan Enterprise License is not free. It's not cheap. I mean, it's not really expensive for what it gives you, but the same code that runs behind Shodan that gives you this information is up on GitHub. You can download a JSON file with a free account, run my Python script against it, and it'll tell you what IPs, the database solution, and then what the database name was, which was a couple slides back, that big list of IPs and weird names. I probably should have been more clear about that. So this got me thinking, 150-odd thousand people on the internet, did all of these people make this same stupid mistake? Did they really go and install Mongo, not read the docs, put it on the internet, not have a password, right? I'm like, doesn't seem that like feasible. So what I started looking at was, well, okay, in Azure, I know that this isn't somebody spinning up a server in their data center, right? They're going and they're saying, okay, deploy something. Actually, we'll pause. Raise a hand. How many of you actually do anything with Azure? It's more than I expected. How about AWS? All right, that's expected. So what I figured out was maybe there's something that's systemic flaw. There's a problem in the way these images are uploaded into the Azure gallery that people are not even realizing this mistake. When we went and talked to customers, we got responses from like, why the F are you looking at my network or my stuff, to I didn't know I had that thing on the internet, right? So it was this weird like imbalance of, it wasn't somebody saying, yeah, I know, I made a mistake, I'm a bonehead. So I started looking into the Azure gallery, and it has this thing called the Network Security Group, which for all intents and purposes is the firewall that's set up with your virtual machine when you spin it up. The fun thing about this is this firewall config is pre-configured by the person that builds the image and puts it into the Azure gallery, right? So whoever publishes that thing, they're like, I think this is a good idea to open up all these ports, right? And if you're not paying attention, when you turn it on, they're all going to be opened up as soon as you spin this thing up. You can configure this during deployment. It's optional. I've tried to get our Azure team to make people look at this before they turn it on, and they're like, yeah, but automation, and then they'd have to actually stop, and they couldn't script all this stuff, and I'm like, okay. Now, the thing that is different now with cloud than it was with the traditional networking that I kind of grew up in is, like with Microsoft, we had these big back-end networks of management backplanes. We could connect in, and we could manage these things over a private, non-routable IP space. Now with the cloud, the only way to get in is SSH or RDP over the internet, right? Most people don't use back-end VPNs into their cloud networks. So I can accept that you're going to have at least maybe 2 ports open, like your management port and maybe whatever the serving plane of the web server, whatever you're wanting to do with this. So I enumerated everything in the Azure gallery, dumped out all of the configs, all of the firewall configs of every single VM, like 3,000 of them that are up there. And the thing that's funny of them is 96% exposed more than management. So I'm like, okay, that's weird. How many other ports are open? 562, this number is probably a little outdated, are the number of just unique and random ports that are opened up by these VM images. The thing that's really scary is there's stuff like 135, 37, 138, 139, 443, or 445. I've seen NFS. I haven't seen Telnet, which kind of blew my mind. I was expecting to see Telnet, but I'm like, you have freaking NetBIOS open to the internet by default. And it's all these big, large commercial storage providers that are like, hey, spin up our storage thing. And it's got every file sharing protocol known to man exposed to the internet as soon as it boots up. Yeah, no finger. The worst offender, who because this is being recorded, won't name, they open up 83 ports to the internet as soon as you spin this VM up. 83. So I've actually reached out to a few people. The one that was the best was Bitnami. I found one of their images had a Mongo port or one of the NoSQL ports, and I said, hey guys, your docs say that you only open up SSH. Like, what, WTF? And in the 2 hours, I got a response from their director. The next morning, they'd fix the image. I'm like, most of the other people were like, no, that's required for the image to work. And I'm like, no, it's not. And if it is, maybe you should tell the users, hey, when you spin this thing up, you're going to need to turn that on, but don't turn it on for them. So for all of you AWS users are probably thinking, oh, it's Azure, it's Microsoft, they're idiots. AWS doesn't work like that. I've had guys from AWS tell me AWS doesn't work like that. Yeah, it does. So it's hard to find and it's kind of buried, but this is the one-click deploy for AWS's Azure or Amazon Marketplace images, and I've redacted this to not shame this vendor. But yeah, they spin up all these by default as soon as you turn the image on. The thing that was tricky is that Amazon doesn't have an API that I can enumerate like I could with Azure. Microsoft, we love APIs. So I can only get a few pieces of information out of there, and I filed a request with AWS saying, hey, it'd really be cool if I could look at the default firewall config before I spin up the image. That was in November. I think they figured out what I'm trying to do, and they're like, no. So Azure has about, like I said, 2,000, 2,500 these third-party VMs that you can turn on. AWS has 11,000 of these things. Now, a lot of them are Amazon or AWS's stuff. And the thing that I find really scary, and I'll touch on this a little bit later, is you can build a VM image in AWS, and you can share it with people. Do you want to run my VM image on your network? Seems legit. So a lot of the other clouds seem to do the same thing, right? So I looked at DigitalOcean, I looked at Google, I looked at Alibaba Cloud, and when I was looking at the attack traffic and all these machines that were getting popped with NoSQL, I'd hit tag compromise, and it's like AWS, Azure, DigitalOcean, it's all the same, the big 5 cloud providers. So I'm thinking, this is a systemic problem. I kind of got bored of trying to dig through APIs after the first 2 big clouds, so I didn't set anything up with DigitalOcean, but if you guys use it and want to ping me later and we can look at their stuff, I'm happy to help. The other thing I found when I looked at these images in Azure, default passwords. So third party, now, because this is being recorded, this is very much the third-party stuff. Microsoft, we have our own images that we publish. We update them every month when we release Patch Tuesday. I actually haven't found any flaws there. It would be really embarrassing if I did, and I would absolutely tell you. So some of these things have a default password configured in the metadata of the image that you turn on, right? And you don't even, the API, I spent a lot of time reversing it out of the PowerShell code, and then I realized we have a GitHub page with the entire thing that's all perfectly documented. I was like, God damn it. I could have just looked at that. But you don't even need to be authenticated to hit this endpoint. You can just hit it with simple HTTP requests. It's like a 12 meg JSON file, enumerate through all of it, pull out all of these configs, and look at them without ever even having to like have an account or any sort of access to Azure. So I found super simple script. It's like, if description contains username and description contains password, flag it as password. So that's not exactly the password. There's like two letters difference. So, I mean, hey, they got the leet speak thing, right? Because that's super secure. And they always say, oh yeah, make sure you change this after the installation. The irony is the biggest offender of this is a company who sells secured and hardened images in the Azure gallery. I'm like, get the fuck out of here. But fortunately, it's just databases, right? Nobody cares about databases, and nobody ever puts databases online. That's global statistics. That's not just cloud. So yeah, there's a few databases out there. I'm not allowed to try to break into customer networks because I'm not on the red team, but I'm sure there's a few databases in our cloud that will probably have these creds that you could still use. So, switching a little bit of gears here. I really enjoyed hunting threats in Azure, trying to protect customers, make the world a safer place and all that. So anytime a new RCE or any sort of a vuln came out, I'd be like, okay, let me go see if I can find how many customers are at risk for this. So this one, it was an XM mail server RCE, and I think it came out back in March. And I'm like, all right, let me take a look and see how many customers are running this. And we should say, hey, like the POC is out there. You guys need to patch this. At the time, there was like 17,000 IPs that had a mail server of some sort, right? 25, 567, 980, don't quote me. You know all the mail server ports. So I was like, okay, at least I could do product XM, right? Shodan, one of the other metadatas is that if it can identify the product that's running, you can search it with a product tag, right? He's got 100-something products that you can find just by searching that. So I downloaded it all and realized that inside the JSON file, it has this part that's called a common platform enumeration field, which is just a standard that's designed to say, okay, this is the version of whatever this thing is. So I was like, okay, parse it out, grep for these things, look for the CPE information. This is actually from the file I pulled down. This is, like I said, back in March. And I was like, okay, this is pretty cool. Out of 17,000, found 1,221 VMs that are running a version of XM and are actually running the vulnerable version of XM. So I was like, okay, about 5 minutes of my time. I'm like, cool, that's pretty awesome, right? 2 million IPs, 17,000, 1,200, 5 minutes. Can it go better? Yes, it can. So I pinged John again. I was like, hey, dude, you know what we should do? You should have Shodan just automatically tag vulnerabilities based on, if I know the CPE number, if I know the CPE platform information of this thing, and I know there's a vulnerability for that thing, because there's a database out there that I think MITRE or NIST puts out that actually maps all this stuff out for you. I was like, dude, you should just tag the stuff automatically. He's like, cool, write the code. I'm like, dude, I don't even work for you. So basically, I did a lot of the legwork, and my day job got in the way. And I said, hey, here's tons and tons of information. And so 2 days later, he's like, all right, it's there. So now, this is another one of those interesting features, only available with the Enterprise API. And this is not something I have code that will give you. You can search by a vuln for CVE across Shodan, and it'll tell you every IP address that's vulnerable to it. Now, probably imagine what this could be used for. The idea that when I talked to him, I was like, dude, you can't make this available to just your average script kiddie users. Like, this will be an absolute nightmare if some dickhead could just go and say, like, oh, I'm going to find everything that's vulnerable. Like that auto pwn script that came out back in March or January-ish. He was livid about that. He's like, God, man, they're just making me look bad. So I was like, let's just make this enterprise only. So if you have enterprise, you can search by vuln, sort it by your organization. If you go and just hit an IP address, like if you search an IP in Shodan, it'll tell you what vulnerabilities it has. So you can see it there from like a single IP at a time. What we didn't want is people just to be able to download a swath of like every vulnerable box on the internet. So this, now I can say, okay, Shodan, tell me how many boxes are vulnerable to this thing in my organization. This was a few months later, so the number had dropped pretty drastically. So that's the top 10 vulnerabilities that are out there on the internet as of a couple months ago. Pretty depressing when you see ones that are like 2013. So the other thing that's interesting, when you look at like the actual details data of an IP address, you'll see this vulnerability and it'll say verified, true or false. When it says verified false, it's implied to be vulnerable. So things like some versions of Apache, Apache 2.2.6 or whatever, there are vulnerabilities out there, but some of it is like, okay, if you have fast CGI or you have these specific modules enabled, then you've got a vulnerability. He's not testing that hard. He's just looking at version data and mapping it out. So if he hasn't tested for it, implied false means, it might be vulnerable, might not be vulnerable. Verified true means that it's confirmed to be vulnerable. For example, MS-1710. He actually tests for the lack of the patches in Windows SMB that's on the internet. So it'll say, yes, this is confirmed vulnerable. I've actually connected, done the handshake, realized it's an unpatched version. But I think it's fairly useful. Another thing I started doing, and I'm kind of jumping around here, I know, I started running a database a year and a half ago. I just pull open port stats out of Shodan for all the major clouds by the 5 largest countries and then globally, and I just do it every day and I dump it into a Mongo database that's on the internet. No, I'm kidding. I just dump it into a MySQL box and I can just kind of watch trends, right? I like patterns. It's one of my things. So I'm like, okay, let's see maybe something stupid. Like if I see a weird spike of some port in Azure, I'm like, what is this? Like new level of retardation. So I noticed this thing called MQTT. Which is the mosquito messaging protocol. It's like a message brokering thing. I'd never really heard of it, and then I started digging around. I was like, oh, it's very popular with IoT. Facebook Messenger apparently uses this thing. I don't use Facebook, but if you do, that's probably why your phone's always going off at you. Azure and AWS both offer these MQTT solutions, but here's the spooky thing I found. In the last year, internet exposure went up by 1,500%. So this little screenshot I took the other day when I was updating these slides, and I'm like, well, that's weird. I'm like, that number seems way higher than it was in March. And then I go and look back, and I'm like, wow, it went up by almost 500,000 machines in 12 months. So MQTT in and of itself, maybe it's not a vulnerability, maybe it is, but here's some creepy stuff you can do. This is where it gets fun. So when I went to Germany to speak at Troopers this year and was putting this slide together, and I was like, I wonder what kind of cool stuff I can find with MQTT. Anybody ever heard of a software called OwnTracks? Sweet, I'm gonna blow your minds. So OwnTracks is this open source solution that you can run. It's MQTT based. It has clients you can put on iPhones, Androids, laptops, whatever you want, and it feeds location data to a brokering system. This brokering system is exposed to the internet with no authentication by default. This screenshot, let me step out here. I redacted this because these are all, I did this one night in Germany and this was live and I was like, ooh, that's creepy. I don't really want to have somebody get killed because of my, hackery stuff. So the important one to look at is, I think, Lenovo. So then I said, okay, let me take this Mosquito client and hook into this system. Boom. Let me show me the subscription data. Here's the subscribers, Lenovo. Does that look weird to you? It's latitude and longitude. It's also, let's see, battery percentage of the phone. These codes, I don't remember what they stand for. And then there's actually, it tells you one of these fields that I might have snipped off, tells you the last time it phoned home. So I'm like, okay, I wonder if that's really legit. So I plugged it into Google in the morning and I was like, okay, interesting, but not really, it's just one data point. So I went back from the conference that night, plugged the same IP address, I hit this thing again, looked at it again, pulled out more data. They moved. So that's some poor person, I think that's Czechoslovakia, that's phone is tracking them and sending location data to something that I can see on the internet without anybody knowing that I'm doing it. I found systems in the Midwest that they had a trucking company and they were tracking all their employees with this stuff. And I wrote a little loop script to say hit it, and I could watch every 5 minutes or so I could see where their trucks were going in real time. I'm like, I shouldn't be able to do that. This isn't so much finding compromise, but this is what I'm finding on people putting online. I'm just like, you've got to be kidding me. So Shodan is really cool at finding stuff from the outside looking in, right? I can see all this stuff. I can see ponage. I can kind of use it as a blue team tool versus just a script to the kitty tool. The thing I can't see with Shodan is something coming out of my network, right? And this is really cool. This is stuff that I just put together this week just for B-Sides. And I actually was lucky enough to go to drinks, a couple of drinks, with the guy that built this system, right? Everybody's like, oh, botnets, you can't find them with Shodan, you can't do all these other things with Shodan. No, Shodan. They're not invisible anymore. Has anybody heard of gray noise? So, gray noise is super early. It's a super cool technology. I'm really excited about this. I talked with the guy for hours the other night. Like, he's an awesome dude. He's built me features in like hours that I've asked, and I'm just a beta user. I'm like, dude, what would be awesome is if I could do this and this and this and this. It's got a network of sensors and a whole bunch of clouds that just sit there and they pick up things, port scanning them. They pick up things doing weird brute forcing. They pick up things doing weird like HTTP path stuff, looking for JBoss worms, looking for PHP myadmin worms, looking for, I've got a whole list of them. So what's interesting is Andrew, his name's Andrew, he gave me access to this like 6 months ago. I was apparently user number 2. And I started writing Python code. I was like, dude, this is amazing. Look at all this stuff I can do. So I sent him a script, and he sends it to John at Shodan. And John's like, that's cool. Let's put that in Shodan. So now you can search tag scanner, and Shodan will tell you every box that's been seen scanning the internet or probing the internet via gray noise data. I can't remember if this is an enterprise license thing or not. If you have access, go ahead and take a look. But he's going to be speaking at DEF CON 26. His name's Andrew Morris. He'll be at the AI Village on Friday. It's a really cool technology, and because it's in its infancy, he's super flexible. It's like, you want features, if there's something your organization has wanted or needed, just talk to him. He's very reasonable. I hang out on a Slack channel with him and a bunch of guys from Rapid7 and Binary Edge all day, and we just talk shit about all the stupid things we see online. So the little clippets, what I did with the script that I sent him was say, okay, I'm going to look at, for me, I dumped all of the IPs that he saw from my Microsoft ASN that have been probing the internet. And then I would take each IP and I'd say, okay, now look this up against gray noise, look this up against Shodan, and I would say, if I see that this thing's been probing the internet for, say, RDP, and it has RDP open via Shodan, that box has probably been hacked, right? Somebody got in with RDP and now they're having it do whatever they want. So that's not a feature that Shodan knows about yet. I'm trying to work with them, with Andrew and John, to figure out how we could do this type of a thing. Right now, it's just code that I use. If you actually have a use for this, I'm happy to share it. Find me or ping me on Twitter or whatever. You'll need API keys for both services, though. Yeah, so probably a bot. I've picked up, just coming out of Azure Cloud, RDP worms, SMB worms, SSH worms, Telnet worms, which is weird because Telnet's not usually open in my cloud. The fun thing is some of these script kiddie botnet writers are so arrogant that they'll stick the name of their botnet in the user agent string. So for these things that are doing HTTP probes looking for stuff, it'll tell you what worm it is. So gray noise has this, so you could say, okay, like look for this, like find me things that are seen with this botnet, find me JBoss worms, find me these different vulnerabilities, and you can just dump all the IPs out. He keeps a list of like the top 50 worst networks in the world of like how dangerous they are from probing stuff, and it's mostly Asia. I hate to tell you AWS guys, AWS was like number 47 a couple weeks ago. All right, so here's a fun one. Like I said, I did the MS-1710 vuln. I can't tell you the story of how we got that in detail here. You can find me later. I'll be at Black Hat and DEF CON all week too. So this has probably been talked about too much in the news, but this unnamed government agency had this really beautiful SMB v1 exploit. And when I mean really beautiful, like I see all the O days that come in for Windows, and this one was like, there's the difference between like a researcher or an APT, and then you're like, whoo, nation state. Like if it could shine, it would. Yeah, you're like, wow, dude. Like the only thing they don't do is comment their code. But yeah, so this unnamed government agency put it in their Metasploit clone. And then, of course, like any government agency would do, they lose this thing. So yeah, unnamed? Huh. Hi, NSA. So the thing that was fun about this was, so I came into work that morning when Shadow Brokers put the password out. I don't know why they do this stuff on Friday. But yeah, we spent the whole day ripping through this thing apart. Initially the internet was, oh my God, like Microsoft is going down, like look at this thing. And we spent the entire day ripping through the exploits, looking at the post-exploit modules, testing it out, and we realized we fixed all this stuff a month ago, or almost a month ago. Yeah, a month ago. There we go, 31 days. So at the end of that day, one of our managers posted this thing online. They're like, yeah, we're good, everything's fine. And we're like, all right, and everybody patched, right? I mean, and anyways, even if they didn't patch, no sane person is gonna put SMB online, right? As you'd find out in about 28 days later, yeah, they did. So when this came out, the first thing we did was like, okay, we're looking at the exploit modules. I'm saying, okay, well, let me see how much Azure exposure I need to worry about, right? Like in the morning, we're like, this could be a 0-day that we don't know about. This could be really bad. And of course, because like, what does any script kiddie do when somebody's cool, shiny nation state cool toolkit comes out? They just start spraying at the internet, right? So the thing, you probably all know about this. If you don't, the quick synopsis, most good agencies don't want to burn their precious 0 days, so you don't send them unless you have to. To this end, they had this tool called DoublePulsar, which would very secretly tell you if this machine had been compromised by your sexy SMB 0-day. Shodan couldn't detect this, right? There's no visible signs of compromise at first. There's no database names. There's no like, YOLOs or any of that stuff. So it used this SMB error code, right? You set up the session, you send it this weird command that was unimplemented, and if it had been infected, it would give you a 0x51 response versus a 0x50, which everybody else would do, like SM or Samba and all these other guys will do the same thing. So I had to manually scan all these things. I think some guys from NCC Group were the first ones that wrote a Python script that could do this whole session setup and then test for this thing. So I just dumped it through, dumped the IPs out, did a bash loop and said, okay, test everything in my cloud for this. And I was like, sweet, there's only 50 of these things. Like, at the end of that week, I think then by Monday or Tuesday after the shadow brokers dropped it, I only saw 50 implants. I'm like, out of 14,000 IPs, that must mean that everybody patched, right? So, I mean, I work for MSRC. We're like, dude, mission accomplished. Like, they're like, we fixed it on time. Everybody patched on time. Like, we got nothing to worry about. Like I said, 28 days later, we found out that actually they hadn't patched. I'm not going to bullet point all of these things. Mostly I like to do this comparison, right? Everybody was like, oh, WannaCry, and I'm still, I haven't yet met Marcus. I'm looking for him, though, because I want to shake his hand and also apologize for what my government's doing to him. But the thing that was interesting with WannaCry is it was very childish, right? The most important data point on this slide is the fact that when WannaCry hit, Azure's exposure was 14,000-ish IPs. A month later, 6 weeks later, it went up by 13%. So you'd think like MS-1710, which we probably should have made a bigger deal of like telling people how important it was to patch it. Okay, shadow brokers dropped this 0-day. Okay, if I'm a network guy and I'm like, I know my SMB servers out there, I'm like, okay, I should probably patch this thing. Maybe my hacker dude in the basement is going to be like, oh, bro, look at this. Look at how easy I can pop your Windows server. No, we went up. The thing that was fun with WannaCry, and why my theory has always been that it was a weapons test to see how effective this thing would be, right? It only went after MS-1710, and its propagation was kind of retarded. It was just like a script kiddie wrapping some ransomware around an exploit they didn't understand, versus NotPetya, which is a obviously like cyber attack or cyber warfare attack, right? I'm not going to imply who would want to attack the Ukraine, but right, instead of this, WannaCry, everybody pretty much agrees it launched I think it's Southeast Asia, some SMB machine. Maybe they didn't even mean to hit it. Maybe like, oh, I wonder if that works. They forgot to turn off the propagation when they tested it. NotPetya, they hacked into MEDocs. They backdoored their update system. And they was like, hey, patch Friday. And pushed out NotPetya and took out the Ukraine. In fact, it was so effective, one of the Microsoft satellite offices got even infected with this thing. Like, they had to take them offline because they're like, if this comes back over a VPN, the WannaCry attack was more effective globally, right? I think Maersk went down for a month. I think the stats were something like 50,000 workstations had to be reinstalled because of this. But the thing that was fun, when I started looking at this, I'm like, there was obviously going after Ukraine, right? It's tax software that's only used by that country. It was all very, very targeted. But it got out, right? And how is it going to get out? Well, it doesn't just use a port scan. It has all these other propagation methods, right? PSExec, BBcats, MS-1710 if all else fails, right? This thing was designed that if you get into one unpatched box, you can take out the whole network, right? I don't care. You could have the most up-to-date Windows 2016 server with all your patches. If your one Windows 2000 box gets hit, it's going to PSExec and it's going to ransomware your shiny new. So the VPN thing is what I kind of want to harp on a little bit. That spooked me. I'm like, okay, so this got out of the Ukraine, right? We had to shut down one of our offices because of this. We're like, okay, we can't let this thing back in our network. Has anybody ever heard of ExpressRoute and Direct Connect? Show of hands. Oh, okay. So yeah, then you know what it is. It's a VPN. I'm going to put this a little bit together, right? So bad security hygiene in the cloud. cloud subscriptions that you got, maybe anybody is setting them up, maybe your sales guys are setting them up. They go, I got to do a demo, I got to show off this thing. They're not patching it. You may not know it's there. Your express route direct connect connection comes back to your corporate network. How are you managing your ACLs? I've done this talk a few times. I had somebody tell me, yeah, it's really hard with cloud. He's like, Azure's got so many IPs, so what we ended up having to do was just let your entire Azure IP range into our firewall. And I'm like, you did what? Now, there's ways to do this. I'm not the guy to tell you this because I don't sell Azure. I just point out the flaws. But there is ways to do it. It's not easy. It can be complex. But just allowing the entire subnet, all of our subnets into your firewall is probably not what you want to do. Because, like Mr. Jeffrey Snover says, we spend billions of dollars making Azure secure. We Hyper-V with all of our red teams, with all the things we try to do to make our cloud secure. We built special clouds just for the government, special clouds for Germany. We have special cloud in China, right? We've done all this stuff to try to make it solid, but at the end of the day, what you do with your subscription is your problem, right? If you get yourself popped, sorry. So do all your policies that you have in your internal corporate networks. Are you pushing that out to your cloud stuff, right? You have to stop, people need to stop thinking that I've got my fiefdom of my data center and then I've got this cloud thing. Like if you're setting this up the way everybody wants to seem to move to hybrid cloud and all these like multi-cloud things, like that's your network too, and you shouldn't, if you're not going to let your sales guy turn on something in your DMZ, you probably shouldn't let them be turning on something in a cloud subscription. If you're going to do that, give them their own subscription, put it off to the side, don't let it into your network, like keep them isolated, right? Because you're going to get popped sometime, or you could get popped sometime. The thing about patching, most people probably have a patching cadence, right? A lot of the stuff that I've seen, it's just bad hygiene, right? These aren't like, other than the SMB stuff, this isn't like cool 0 days and nation state stuff. Like this is just like cloud scale permissions problems, right? This is dumb mistakes that we stopped making 15 years ago that are now coming back because cloud's the new shiny and people forget, no, it's basically just an extension of what we've always been doing. People are like, oh, patching causes downtime, right? We hear this all the time. We hear this in Microsoft. My cloud provider does my patching for me, right? The people really love the idea of running in the cloud because they're like, that's cool, man. I don't need a network guy. I don't need a firewall guy. I don't need a server team anymore. I can have my DevOps bro do all of it for me. Sure, you can. But what you just threw away was all the expertise from your network guy, your firewall guy, your server guy, and security guys, right? So you have this one dude who's not to shit on DevOps, but they may not have all these skills, right? I talk with guys that build Azure that are like, packet networking, what's that? It's software-defined networking. I'm like, oh my God. So we do have ways to do this. We can help you with this. I'm sure AWS has the same thing. I'm not a sales guy. I'm gonna kind of breeze over this. There's what we call PaaS and SaaS. Platform as a service, software as a service. What I would love is to see everybody go to software as a service. We patch everything for you. Like we have the stuff when Patch Tuesday comes out, everything underneath your SaaS platform has already been patched for you. You don't even have to think about it. It doesn't reboot. You never even notice it. Just fire and forget. You're good. PaaS is a little bit more complicated, and not everything runs in SaaS, right? It's something we kind of have to build the platform that supports it. So if you can't run it in SaaS, you can run it in PaaS. There's this shared responsibility model. You have to set up how you want the patching to happen with PaaS, right? They have these things, I think they call them failover domains, where basically it's like load balancing networks. Like if you ever worked with like an F5 load balancer, you've got all my web servers, and you're like, okay, we need to patch that one. We take it out of service, we patch it, reboot it, put it back in service, allow the rinse repeat. That's kind of what PaaS does, right? You say, okay, these are my resources, these are my failure domains. That way we know, okay, this is the first thing to patch. We push it over to this other, worker set. Reboot this, now we can patch the other one. It's minimal to almost no downtime, but you do have to think about it or talk to your friendly Azure sales person, I guess. So I'm done with the salesy stuff. I was asked to put that in, so I'm not like gloom and doom and the cloud is like coming down on top of us. It's totally coming down on top of us. So supply chains. Cloud marketplaces, as I've kind of been crapping on how they're bad firewall configs, they have default passwords, they're set up by somebody else that you don't know. It's some guy that built it for whoever cloud that they uploaded it to. One of the funny artifacts I found in Azure was somehow during the packaging process where you build the VM and you upload it to Azure, you basically say, okay, here's my thing, and we package it all up. All of these files get uploaded and put in as what they call artifacts, which are these different little little things. Some of them are like setup scripts, some of them are like firewall setup scripts, or I've seen some weird ones that are actual like bizarre shell scripts that are apparently supposed to run once the thing turns on. Like it's very hard to reverse engineer what this thing is doing. But the thing that's funny is I find things that are like, it'll be like named .macOSX/desktop. And I'm like, you just pulled every file out of that machine and uploaded it there. These are supply chains, and we have to think about it like that, right? Being in part of Microsoft, the CCleaner thing was really spooky, right? Because that came out, and we're like, wow, that's internal Windows build networks. Like, those aren't on the internet. You used to be able to search and not even find them on the internet until CCleaner came out and was like looking for them. This happened a couple weeks ago, or maybe a month ago. Docker, they found all these machines that have been backdoored, running out of Docker Hub, mining cryptocurrency for whomever. Monero drives me nuts because I can't track any of it. They're really good resources, right? Most of the people that are going to go into a cloud network, well, you know that there's a super powerful box underneath it. You also know that it's probably a business or somebody, you know, it's not like going after an ISP network. Like, these are businesses, like these are high value targets, and there might be some really cool stuff if you can bounce through a, ExpressRoute connection back into their network. There's also minimal validation. These third-party images, I went through the publishing process, or I looked at the publishing process for Azure, and it's like you set up a business license, you fill out some paperwork, you wait a little while. It's a little bit more difficult than buying a gun, I guess. But yeah, once you're done, you have a publishing license. You can put whatever you want in the Azure gallery for anybody to use. So I asked my boss, I'm like, so could I build a VM image and put it in there and do some stuff? And I threw a few ideas of like, well, we could set up a timer script to do a little bit of Monero mining, or we could just start probing the metadata instances and finding out the subscription IDs of where these things are being turned on, or because the firewalls allow all outbound connections by default, just pop a callback to myself every time somebody spins up a VM image. I would almost bet money that there's somebody doing this already, right? We're not going to see it. There's probably some guy in Southeast Asia saying, oh, look, new Azure VMs turned on because it just called home. They do a virus scan on it before they put it up there. They're also really old. So the only interesting piece of data I could really get from the AWS side was the age, and I can get the age from the Azure images too. The average age in Azure of these things is 172 days. AWS, 717 days. Now, that was in the spring that I looked at it. It might be worse now. I'm sure there's a couple of vulnerabilities that have come out for most of those things in the last 2 years. The thing that's fun is, even if we did find, and even if someone would say somebody puts a VM image up there, it's malicious, it's doing bad things, it's being used by customers, people are getting their cryptocurrency stolen. If we find it and we shut it down and they fix it, everybody that deployed it still has to fix it themselves. It's not retroactive, right? With PaaS and SaaS, if there was something wrong with the underlying image that ran those PaaS and SaaS machines, as soon as we fixed it, all those things would be fixed. With these third-party IaaS images, when you spin it up, you've copy and pasted whatever that thing is into your network. It's not going away until you fix it, or you know about it, or you find yourself in trouble. And there's no way around this. It's just the nature of how these infrastructure as a service works. So 2018, when I first started doing this talk in the spring, I theorized that it would be the year of the CryptoMiner. And now I keep seeing all this stuff all over the internet. And I was like, I should have made a bigger deal about it. Then I could be like, I said it first. So the one thing I hate about Monero is I didn't get in back in like September of 2016 when it was like $1 a coin. Now it's like $500 something a coin. Everybody's going to that, right? Ransomware is really useless. I mean, it's destructive, but it's noisy. It kills the host. People catch it really fast, right? I mean, WannaCry, people knew within minutes. They're like, oh crap, something's going wrong. Crypto mining, you can just run it. And if you're not super greedy and you don't take over the entire CPU, you could probably run it for months before somebody even noticed. Attackers figured this out and started to change their NoSQL attack campaigns. I forget when this was that Trend found out. They're like, yeah, this CouchDB thing that they used to just be dropping the database out of, they're not doing that anymore. They're putting crypto mining software into it, right? So they're like, okay, like nobody's going to send me Bitcoins. I'll just make some Monero on my own. S3 buckets. I think the LA Times a couple months ago, somebody managed to drop CoinHive in there, and people going to the LA Times were getting hit with CoinHive. Like every day I'm seeing like, oh, crypto this, crypto that, crypto that. I'm kind of sick of the term, honestly. And anything that they can get into, that's the thing that's spooky. This is a very technology agnostic or a platform agnostic thing, right? I could do it on a Mac, I could do it on a Linux box, I could do it on a server, I could do it on a phone, I could probably do it on a smartwatch if I really was that patient. So yeah, this Oracle server, $250,000 they made before anybody even noticed. Granted, it's Oracle, so it probably had like 1,000 CPUs, but still. This is one that I found in Azure. This is my last compromise thing. When I was in Germany, I was turned on to this. Somebody said, hey, I have a thing for you, but you can't tell anybody who I am because German law, by the fact that I even looked at this, was technically breaking the law. So this individual, who's not named or credited, he's like, yeah, look at these Docker ports. So I go and look. I'm like, oh, that's an HTTP admin port. There is no authentication by default. This was like Docker v1 HTTP interface, or the admin interface, right? I don't know. Oh, good. I tried to brighten this up. This does actually show up fairly well. So what they did, and what I ended up doing was just pulling out all the IPs again and looking for xmrig CC, xmrig daemon. What was interesting is the naming constructs. Yeah, here's the funny one, right? Kind Smart, right? Or Kind Swartz. The thing that was interesting with like the NSA stuff is they had all these weird names like DoublePulsar, Eternal Blue, or all these goofy things. These guys in their Docker mining, or their Monero mining campaign, were using very similar names. It was like these weird, like it almost looked like a spammer. Like you get emails from these weird people, and you're like, but that isn't. Is that even a real name? There was thousands of these things all over the internet. They basically just got in, dropped this xmrig daemon, I found ones in Alibaba Cloud. It must have been a bot because they were putting in like 50 of these things on the same host. Right, there would be a little bit different in the name, but it was like 50 xmrig daemon processes. I'm like, dude, you're greedy. Just leave it with one. Like, I don't really know how the mining thing works. Maybe it's more efficient to run 50 of them on one box. The thing that was interesting was the guy that told me about this said, hey, they're proxying all this Monero mining traffic through these Monero proxies. So apparently it looks bad if you have mining coming from like 10,000 IP addresses for your one wallet. So they hacked an Azure customer in Europe, put this system, this Monero proxy onto a couple of their VMs, proxied all their mining traffic through these two VMs. They had the code on GitHub. like the guy's like, yeah, he's like, I wasn't sure if what they were doing, if it was legit, so I sent them an email. He's like, and 2 minutes later, they just deleted the repo entirely. He's like, but here's the Wayback link to look at it. And I'm sitting there, I'm like, yeah, they basically just set this up, mined Monero. If anybody knows how to track this stuff, I'd love to know. As far as I know, it's untraceable, so I don't know how much they made. And the fun part was we had to get our lawyers involved because hacked customers were being used to hide traffic from other like illegal activity, right? So we couldn't just turn them off. These were paying customers. So we're like, ugh. I'm so glad I'm not a lawyer. I just basically threw it all over and said, you guys deal with it. It's gone now. So yeah, shout out to Troopers for connecting me with folks like that. I hope to meet more folks like that here, DEF CON Black Hat. So, final slide, kind of wrapping this up. Some takeaway points if you're running in the cloud. If you're going to run IaaS, especially if you're going to run third-party IaaS, update that shit as soon as you turn it on. Like, you don't know how old it is, you didn't build it, you have no idea what it's running. Like apt-get update or Windows update or however Debian does or Red Hat does it these days. Just do like you would with your normal network. Don't assume that because it's there, Microsoft is making sure that it's updated. We're not. We let them put it up there. It's like Google Play Store for cloud VMs. Check the firewall settings before you turn this thing on, right? Same rationale behind the updating it. You didn't set it up. You don't know what they did. 83 firewall ports to open to the internet? No. The other thing you can do for some roles, PAS and SAS just don't work, right? You might have some interesting middleware or something that you have to do that you depend on. You can build your own image. Like if you're paying subscriber, I know AWS does this, I know Azure does this. Build your own image, get it all tuned, get it all set up the way you want. You can publish it to your own subscription, and then only you can use it, unless you share it in AWS. But that way you can say, okay, if you're selling widgets and you need to do this all the time, that's the one you guys turn on. If you have a specific role, at least you know who built it, right? It's like you did with your fiefdom, only now it's in the cloud. I've been trying to work with the Azure team to get better information about this for just public-facing stuff, right? The age of the image isn't exposed anywhere to you as a user. Like, it's in the API, but when you go to turn it on, it just says, here's the thing, it's new and shiny. No, it's not. It's like 1.5 years old. So working on that, trying to get them to block the firewall policy stuff. What I'd like them to do is give me version information of daemons and services too, so I could say the next time there's like a shell shock, I say, okay, show me every VM image that has this specific version of this thing. And I can say, okay, now turn those guys off and don't let anybody deploy them until they're fixed. If that ever happens, I'll put it on Twitter and brag about it. And then last point, if you use Azure, you can get free stuff from Azure Security Center. It's like basic security stuff that you probably can do yourself if you're here at B-Side. So that's what I got. Thank you very much for having me, and I think I've got like 9 minutes.